Okay, so what I'm going to do in this video is look at checking the divisibility of numbers. So I'm going to look at particular numbers and I'm going to see, are they divisible by 1? Are they divisible by 2? Are they divisible by 3? All the way up to 12. Now I'll do some examples and at the end I'll do a couple of proofs. If you're only interested in the rules, you can skip the end of this video and forget about the proofs. But we're going to start with the number 1. Now, all numbers are divisible by 1. So if you take 256 divided by 1, you'll get 256. If you take minus 45.5 divided by 1, you'll get minus 45.5 and so on. So that's easy enough. Number 2 then, 2 will divide into all even numbers. We're just going to look at even numbers. So even numbers will end in 0, 2, 4, 6, or 8. So for example, if you take 256, this ends in a 6, so therefore this number here is an even number, therefore it is divisible by 2. The reason for this is because this number here is made up of 200, that's this part here, plus another 50, which is this part here, plus the units, which is 6. So we know 200 and the 50 parts are going to be divisible by 2. So all we've really got to do is check the last digit, which is 6. See, is that divisible by 2? Which it is. So therefore the entire number is divisible by 2. So if we had 257, for example, the number at the end here would be a 7, which is odd. 7 is not divisible by 2, so therefore 257 is not divisible by 2. Okay, so let's have a look at the next one then. We're going to take the numbers 3 and 9. I'm going to lump those two together because they follow the same rule. Let's have a look at some examples. So if we take the number 78, for example, all you've got to do is add the digits. So if we take 7 plus 8, that'll give us 15. Is 15 divisible by 3? Yes, it is. Is it divisible by 9? No. So this number here would be divisible by 3. If we take 2,961, add the digits, so it's going to be 2 plus 9 plus 6 plus 1. That'll give us 18. Is 18 divisible by 3? Yes, it is. So this is divisible by 3. Is 18 divisible by 9? Yes, it is. So this is divisible also by 9. Let's take another one. 411,282. So this is 411,282. So again, add the digits. 4 plus 1 plus 1 plus 2 plus 8 plus 2. So if you add those, you'll get 4, 5, 6, 7, 8, 8, 16. You'll get 18 as well. So we got 18 again. So again, this is divisible by 3. It's divisible by 9. So again, this is divisible by 3 and 9. Let's do one more. Let's take 47251. So this is 47,251. Okay, so let's just add these digits. So you've got 4 plus 7 plus 2 plus 5 plus 1, that's 7, 8, 9, 10, 11, 12, 13, 18 plus 1, which is 19. So 19 is not divisible by 3, so this is not divisible by 3. 19 is not divisible by 9, so this is not divisible by 9 either. Now this is one of the ones I'm going to do a proof for later on, so if you're interested in that, you can have a look at that. If not, just skip the end of this video. The next number is 4. So to check if a number is divisible by 4, all we need to do is look at the last two digits of the number. If the last two digits of the number is divisible by 4, then that number is divisible by 4. So for example, if we take the number 248, let's just look at the last two digits, 48. If we take 48 divided by 4, we do get a whole number, we get 12. If you take the number 1460, look at the last two digits, take 60, is that divisible by 4? Well, if you take 60 and divide it by 4, you will get 15, so this is divisible by 4. If we take a bigger number, let's say 102,792, again, just look at the last two digits, take 92, divide that by 4. Well, 4 into 9 twice, 1 left over, that's 12, so 3 4s 12, you get 23, so no remainder, so this is divisible by 4. Let's take another one then, one more, 13725, so 13,725. Let's take 25. If you take 25 divided by 4, we'll get 6, and we'll have a remainder of 1. So we do have a remainder here, so that means 25 is not divisible by 4. That means this number here is not divisible by 4. Okay, so the reason for this is if we take, for example, the number 23,584, we can see that this number is divisible by 4 because 84 is divisible by 4. But this number is made up of 20,000. So that's from this number here. You got a 2 and a 0, 0, 0, 0 here. So that's 20,000. We've got to add 3,000. So that comes from this digit here. This is 3. Then you got 1,000 here. And we've got a 500 here as well. So we can add 500. And then we can add an 80. And then we can add our units, which is 4. So this is how the number is made up. Well, any number out here, 20,000, 30,000, 40,000, 50,000, 60,000, so on, that's always going to be divisible by 4. This number here is also going to be divisible by 4. 3,000, 2,000, 1,000, 5,000, 6, 7, and so on. These are all going to be divisible by 4. The hundreds are always going to be divisible by 4. Problem is here, not all the tens are going to be divisible by 4. So 10, for example, if this 8 was a 1, for example, that's not going to be divisible by 4. 2, if that 8 was a 2, if this was 20, for example, that is divisible by 4. 4 5s will give us 20. If this 8 was a 3, that's not divisible by 4. So the problem was with the last two digits. So that's why we just look at the last two digits to see, are the last two digits divisible by 4? If they are, then the whole number is going to be divisible by 4. Okay, so the next number then is 5. So if we take 5, any number ending in a 5 or a 0 is divisible by 5. So if you take 250, it's ending in a 0, so that is just 50 when you divide by 5. If you take 3475, 3,475, that ends in a 5, so that number again is divisible by 5. This again is because if you take this number here, it's made up of 3,000 plus a 400 plus a 70 and then plus a 5. So these are the thousands, the hundreds, tens and units. So any thousands is going to be divisible by 5. Hundreds are going to be divisible by 5. Tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. They're going to be divisible by 5. And then all you've really got to look at is the number at the end. So if you take 3, 4, 7, 5, 6, for example, that ends in a 6. That's not divisible by 5. Okay, so let's have a look at 6 then, the number 6. So what numbers are divisible by 6? So again, this is easy enough. So the number must pass the 2 and the 3 test. So it must be divisible by 2, and it must also be divisible by 3. So you check to see is the number divisible by 2 by applying the 2 rule and 3 by applying the 3 rule. That's really it for 6. So the next number is 7. Now 7 is probably the trickiest one of the lot, but we'll run through it anyway. I'm not sure how much of an advantage it is to use this technique, but let's start with, well, if we start with 2-digit numbers, I'm going to assume that you know your 7 times tables. So we'll actually move on to 3-digit numbers. I'm going to do some examples. So let's start with, let's say, the number 672. The way you do this is you take the first two numbers here, 67, you subtract twice this number here, so it's twice 2. So that will give you 67 minus 4, which is 63. Is 63 divisible by 7? Yes, it is. So therefore this number here is divisible by 7. 7 9, 63. So let's take another one. So if you take 413, again, same thing again. Let's take the 41, subtract twice the last digit here, twice the 3. So when you do that, you get 41 minus 6. So that's just equal to 35. Is 35 divisible by 7? Yes, it is. So this number here is divisible by 7. Let's pick a bigger number then. So 4,606. So what you do here is you work backwards from here and you divide the numbers into sections of 3. So we've got 1, 2, 3 here. So I'm going to put a little comma here. So I'm going to take the 606 and I'm going to subtract 4. So if you do that, you get 602. So now we have our 3-digit number here. So you use the 3-digit number technique. So we'll take the 60 minus twice the last digit. So that's 60 minus 4. So that's 56. Is 56 divisible by 7? Yes, it is. So therefore this number is divisible by 7. Therefore this number here is divisible by 7. Okay, so let's go a little bit bigger. So I'm going to look at 46,123. So again, divide them into sections of 3 numbers. So I'm going to put a comma here. So we have these 3 numbers here, and we just have 2 out here. Let's do the same again. We're going to take the 123. We're going to subtract 46. So if you do that, you'll get 77. 2-digit number. 77 is divisible by 7. So therefore this number here is divisible by 7. Okay, let's go again. Let's take 319,823. So again, divide it into segments of 3. So there's 3 there and there's 3 there. So take the 823, subtract 319. So that gives us, let's see, 504. Take the 504, 3-digit number, take the 50, subtract twice the last digit, which is 4. So 50 minus 8, so that's 42. So is 42 divisible by 7? Yes, it is. So therefore 504 is divisible by 7. Therefore 319,823 is also divisible by 7. Okay, just a couple more examples. So let's take 6,275,829. So again, let's divide them into segments of 3. So we got 3 here, we got 3 here, and then a 6 at the beginning. So we're going to take the 829, we're going to subtract 275, and then we're going to add the 6. So we're doing alternate sums here. We're adding, then subtracting, then adding, then subtracting, then adding, then subtracting, and so on. So we have 829 minus 275 plus 6. When you do that, you get 560. Again, a 3-digit number. Take the 56, subtract twice the last digit, which is 0. That'll give us 56 minus 0, which is 56. Is 56 divisible by 7? Yes, it is. Therefore, 560 is divisible by 7. Therefore, 6,275,829 is divisible by 7. Okay, let's go for one more. We'll go for 41,276,123. So again, we divide it into sections of 3. So here, here, and 41 at the beginning. So do our alternate sums. So we're going to take 123, we're going to subtract 276, then we're going to add 41. So when you do that, you get minus 112. So we're going to ignore the minus here. It's a 3-digit number. We're going to take the 11. We're going to subtract twice the last digit, which is 2. So it's 11 minus 4, which is 7. 7 is divisible by 7, so this is divisible by 7, so this is divisible by 7. So as I say, not a particularly easy one to do, but that's it for 7. Okay, let's look at our next number then, which is 8. So let's start with a 3-digit number, let's say 288. Again, I'm going to assume you know your 8 times table, so that'll cover all the 2-digit numbers. So what you need to do here is take the first 2 digits, which here is 28, you double 28, and then you add the 3rd digit. So add the 8 at the end. If you do that, you get 64. So you look at 64 and you say, is that divisible by 8? If it is, then this number here is divisible by 8. Let's look at another number. Let's look at 292,384. That's 292,384. So again, this number here is made up of units, tens, hundreds, and so on, higher powers of 10 after that. So let's see, we have 200,000. That's this place here. So it's 200,000 plus 9 here, so that's 90,000 plus this here is just 2,000 plus 300 plus 80 plus 4. Now if you start from here and work this way, you'll notice that all the thousands are divisible by 8. All the 10,000s are going to be divisible by 8. All the 200,000s are divisible by 8. And all higher powers of 10 then in this direction are going to be divisible by 8. So 2,000, 1,000, 3,000, 4,005 up to 9,000, 10,000 up to 90,000, 100,000 up to 900,000 and so on. They're all divisible by 8. So we don't have to worry about these ones. The problem is with the last 3 digits. So really all we've got to do is concentrate on 384. So again, we apply our rule. We take 2 times 38, we add 4, and that'll give us 80. So is 80 divisible by 8? Yes, it is. So therefore, this number here is divisible by 8. Now, again, I'll do a proof on this if you're interested in it at the end. Okay, so the next number is 9. We've already done that. 10 is just any number ending in 0. So for example, 950, that's divisible by 10. You just get 95. 9730, that's divisible by 10. You just get 973. 11 then. 11, let's look at some examples of numbers that are divisible by 11. So we take 616. Again, I'm just starting on 3-digit numbers. What you do is start at the end, work this way, and do alternate sums. So in other words, we're going to take 6, which is a plus 6, then we're going to subtract the 1, and then we're going to add the 6. So we're taking plus 6 minus 1 plus 6, working in this direction here. So if you do that, you get 6 minus 1, which is 5, 5 plus 6, which is 11. 11 is divisible by 11, so this is divisible by 11. Let's look at another one, 62,678. 62,678. Now these numbers are divisible by 11. So let's start again at the end, work this way. So we're going to take plus 8, minus 7, plus 6, minus 2, plus 6. So if we do that, let's see, we've got 8 minus 7, which is 1, 1 plus 6, which is 7, 7 minus 2, which is 5, and then 5 plus 6, which is 11. So again, 11 is divisible by 11, so this number is divisible by 11. So let's look at a bigger one then. Let's take 62,686,195. So this is 62,686,195. So a bigger one. Let's start at the end then. So we're going to take plus 5, minus 9, plus 1, minus 6, plus 8, minus 6, plus 2, minus 6. So let's see, if we do that, we get 5 minus 9, which is minus 4, minus 4 plus 1, which is minus 3, minus 3 minus 6 is minus 9, minus 9 plus 8 is minus 1, minus 1 minus 6 is minus 7, minus 7 plus 2 is minus 5, minus 5 minus 6 is minus 11. So minus 11 is divisible by 11, so this is divisible by 11. Okay, so that's 11 done. Let's have a look at 12. So if we take 12, well, really with 12, you've just got to look at the test for 4 and 3. It must pass both of those tests. So we've done those earlier. So you apply the 4 test, you apply the 3 test, and if it passes both, then the number is divisible by 12. Okay, so at the beginning I said I'd do as far as 12, but if you've gotten this far and are still awake, I'll throw in a bonus number, let's say 13. Number is divisible by 13. So there's a very simple rule here. Let's take 468. What you do here is you take the first 2 digits, 46, and you add 4 times the last digit. So 4 8's 32. If you add those two together, you get 78. Is 78 divisible by 13? Well, let's just apply the rule again. You take this digit here, 7, add 4 times the last digit, 4 8's 32, and you get 39. So is that divisible by 13? But let's try that again. Take the first digit 3, add 4 times 9, so 4 nines, 36, and look, we just get 39 again. So we're just repeating at this stage, but you can probably see anyway at this stage that 39 is divisible by 13. You could probably see that 78 was divisible by 13, but anyway, this is going to be divisible here by 13. Let's try another number, a bigger one. Let's take 8, 5, 6, 5, 7. So you take all the numbers except the last digit, so that's 8, 5, 6, 5, and you add 4 times the last digit. So 4 sevens, 28. So if we add 28 to 8,565, we get 8,593. So we can go again, take 8, 5, 9, add 4 times 3, which is 12, and that'll give you 871. So again, let's take the 87, add 4 times the 1, which is 4. That'll give us 91. And we can go again one last time. This is divisible by 13, but if you don't spot that, you can take the 9, add 4 times the 1, which is 4. That gives us 13. 13 is divisible by 13, so is this, so is this, so is this, and so is this. Okay, so with all the examples that I've done from 1 to 13, I've just done one rule for each. There are other ways of doing them, and you may find some of those easier or more difficult. But in this section, what I'm just going to do is look at 2 proofs. First one is just the proof that a number is divisible by 3 and 9, that particular method. So let's just look at an example first of a number. Let's take 34,567. If we take that number, it's made up of 30,000, it's made up of 4,000, it's made up of 500, it's made up of 60, and it's made up of 7. So if we were to add those numbers, we would just get 34,567. So this is the units, the tens, hundreds, and so on. So the 30,000 is just 10 to the power of 4 multiplied by 3. The 4,000 is just 10 to the power of 3. 10 to the power of 3 is 1,000, and we multiply that by 4. 500 is just 10 to the power of 2 multiplied by 5. 60 is just 10 to the power of 1 times 6, and out here we just have the 7. So what I'm going to do is I'm going to say these things here, I'm going to call these numbers here x's, and I'll show you that in a second. So let's write out a number algebraically then. So if we take our number, we'll call it n. Our number is going to be made up of 10 to the power of some n. Here I've only gone out as far as 4, but we're going to go out as far as n, and then we're going to multiply that by some x, and that x, we'll call it xn. You're going to add another 10 to the power of n minus 1, the next one down, this one here for example. Then you're going to multiply that by some other x, we'll call it just x n minus 1, and so on. You're going to keep doing that until you get as far as 10 times x, and then we'll call it x1, and then out here as far as x0. So that's kind of down here. So this is my number. So what I'm going to do now is just apply the rule. Remember, the rule for 3s and 9s is that we just do the cross sum. We add up the individual digits, and if the result is divisible by 3 or 9, then the original number is divisible by 3 or 9. So remember, what we've got to do here is add up these numbers here. Those numbers there, in this particular case, are going to be these x's here the whole way down along. So let's add those. So our test number, we'll call it t, is xn plus xn minus 1 plus xn minus 2, and so on, all the way down to x1 plus x0. So in other words, if we add these up and the result is divisible by 3 or 9, then the original number, this number up here, will be divisible by 3 or 9. So what I'm going to do now is just subtract these two. I'm going to take n minus t. So if I do that, here I'll subtract these two. So I'll get 10 to the power of n x n minus xn plus 10 to the power of n minus 1 xn minus 1 minus xn minus 1 plus all the way down to these two here, 10 x1 minus x1, and then at the end here these two will just cancel. I'll get 0 there. Okay, so if we look at that, then our n minus t, our number minus our test number will just be, I'm going to factorize out the x's. So it'll be 10 to the power of n minus 1 xn plus 10 to the power of n minus 1 minus 1 xn minus 1 plus all the way down to 10 minus 1 x1. Okay, so let's look at this number, our n minus t. So our n minus t then, how is that actually made up? Well, if we look at this number here is just a 9. 10 minus 1 is just 9. Now if we look at, let's say we start up along here. So this here is just going to be some power of 10. So it's going to be 1 with a lot of zeros after it. If we subtract 1 from it, we'll just end up with a lot of 9s here. If we look at this one, this is just going to be a 1 with a lot of zeros after it. Subtract 1, this is just going to be a lot of 9s. So each term in this expression here is just going to involve an xn with a lot of 9s as the coefficient. So in other words, we can factorize out the 9 here. We can say 9, and then if we factorize out the 9s from all of these, we'll just end up with some whole number here. So if we take our original number, which is n, that'll be 9 times some whole number plus t, plus our test number. Now, if we look at this then, what have we got? We've got our original number here as n. This here is divisible by 9, obviously, because if you divide by 9, you'll end up with a whole number here. If our test number, if what we get when we do the cross sum, if what we get when we add up all the individual digits is also divisible by 9, what we'll end up with here is 9 times a whole number here plus 9 times, again, some whole number here. This is if this test number is divisible by 9. So you can see here that this number here is just going to be, we can factorize out the 9, and we just end up with 9 times some whole number. So our original number will be divisible by 9. And that's the proof for your 3s and 9s. Because if a number is divisible by 9, it's also going to be divisible by 3. Okay, let's look at our second proof. The second proof I want to do is just the 8 rule, divisibility by 8. So let's look at an example of a 3-digit number first. So I'm going to look at 472. Now 472 is made up of 400 plus a 70 plus a 2. So units, tens, hundreds. So the 400 is just 100, and you got to multiply that by 4. 70 is made up of a 10, which you got to multiply by 7, and 2 is just 2 down along here. So again, I'm going to just call these ones n's. So these are going to be n's, and I've just got multiples of 10 here, or powers of 10 along there. So if I take 472, the rule is that you just take the first 2 digits and you multiply by 2. So it's 2 times 47. Then you add the final digit, which is 2. That'll give us 96. So 96 is divisible by 8, so this is divisible by 8. So let's write out a number then, a 3-digit number. Again, we're just going to call this n. This proof is very similar to the previous one I did. So it's going to be 100 times n. 100 times n. Let's call it n2. We're going to do n2, n1, and n0. Then we're going to add, the second one is just going to be 10 times an n1. And then we're finally just going to add an n0 out at the end. So this is our number. This represents any number. So let's look at our test number then. So how did we work out our test number? Well, we took twice this 2-digit number here, and we added this number here. Now remember, this number here is not 100n and 10n if we take it as a two-digit number. For example, if we take 47 as a two-digit number, that's just going to be 10 times 4 plus 7 times 1, if you like. So in other words, we've got to take twice 10 and 2 plus n1. This is our two-digit number. And then we've got to add the n0 at the end. So now what I'm going to do is just multiply that out. That'll give us 20n2 plus 2n1 plus n0. Now we're going to just subtract these again. So we're going to take the n minus t. So that'll give us 100n2 minus 20n2. That's 80n2. We're going to take the plus 10n1 minus 2n1, so that's plus 8n1, and then this here will just cancel. So that's equal to, you can probably see where we're going here, we can factorize out the 8, so we get 10n2 minus n1. So this is our n minus our test number. So again, what we can do here is just take the original number, bring the test number over to the other side, so that'll give us 8 times 10n2 minus n1, which is obviously divisible by 8. We can add the test number here. So again, what we can say here is that our original number is n, which is equal to some number here that's divisible by 8. And if this number here, if our test number is divisible by 8, what we get here is 8 times 10 times n2 minus n1 plus, if this is divisible by 8, we can factorize out the 8 and we just get some whole number here again. Okay, so we can see then that the original number will be divisible by 8 because this is divisible by 8 and this is divisible by 8 here. So therefore our rule works for 8. There are the two proofs that I just wanted to do. There are other proofs as well, which I'm not going to get into, but that is the end of this video.